Hi, welcome to the next lesson in the Server 2012 Advanced Services course. We're focusing on Hyper-V failover clustering logic. We've already explored how to create an iSCSI target and be able to map to it. We've explored how to be able to create a failover cluster. We've talked a little bit about virtualization and its benefits. Here we're knitting all those ideas together into one coherent whole. So we've got our virtualization platform up and running. The boss is delighted with the economic savings of having all of our servers on one box. And then we get the phone call from our hardware vendor, because one of the components of one of our failover cluster servers running Hyper-V is defective. They've issued a recall. So what they want us to do is to shut down that server, take out that part, ship it to them so they can ship us a new one. My problem, of course, is I've got mission critical functionality running on that server. I can't just take it offline for a week or two while we ship that part around. We've got arrangements with other departments in the company that if we don't keep certain of their servers up a certain percentage of the time, that's going to reduce the amount of money that IT can charge back to their department for the use of our IT services. And one of those virtual machines belongs to some third-party company who's renting space in our data center, and we've got a contract with them that says we'll keep that server up a certain amount of time, or we lose money in that deal. So what are we going to do to make sure that that virtual machine is up as much as possible? Well, we've got a couple of tools at our disposal, and we'll explore them here. One interesting variation on the theme is the idea of storage migration. Virtual machines are described by configuration files, plus one or more virtual hard disk files that describe the content of their hard drives. All that data resides somewhere. In a case where a hard drive is getting full and I want to migrate certain virtual machines off of a drive that I intend to decommission to install a larger one, it becomes necessary to have an easy way to get the storage for one VM off of one disk onto another. One historical challenge with that was the possibility that the virtual machine would have to be turned off to be able to migrate those files. Interestingly, failover clustering in Server 2012 allows us to migrate just the storage of a virtual machine from one host to another while the virtual machine continues to run. And that's a neat feature. Behind the scenes, we're going to make a copy of the VHD file from one server to the other. Once that synchronization process is complete, a signal goes from the failover cluster to the VM to change which location it looks for. Once that's done, the failover cluster sends a signal to the virtual machine to tell it which location to look in to go find its configuration files and its VHD files, and that VM continues running as if nothing had changed. Another interesting feature, and not a new one, this was part of Server 2008, is quick migration, in which I can take a snapshot of what the computer looks like on one side of that connection, saving all of its memory state and processor state to a set of files, seeing how those files are in shared storage, they're accessible to my other failover cluster nodes. I can then restart that virtual machine on another node, retrieving the data from the hard drive, copying it back up into memory, restoring everything back to where it was, and off we go. That can be a nice quick migration, something that's a matter of seconds or a minute or two, depending upon the quantity of data in the system at the time that I go to perform that operation. Let's take a look at a demonstration of that. So here I am in my lab environment. I've got a pair of Hyper-V hosts. They are in a failover cluster. At the moment I've got a virtual machine on host 2 called failover demo. And what I'd like to do is to be able to fail that over to host 1. Hyper-V host 2 has a bad network adapter card that I need to replace, so I need to shut down the server so I can extract that piece of hardware and replace it. Meanwhile, what do I do with my virtual machine? Well, I don't want to turn it off for the time that I've got the overall host down. I want to move the VM off onto some other host. So how do I go about that? Well, to be able to test this, I want to be able to kind of see what the reaction of the migration is on connectivity to this virtual machine. So what I'm going to do here on the failover demo virtual machine, I'm going to go launch a cmd.exe prompt and do a quick ipconfig, wondering where am I? And I am on 192.168.15.13, that's the IP address of this computer in its LAN. So what I'm going to do is I'm going to open up a PowerShell prompt here on my host computer, and I'm going to go ping that .13 IP address repeatedly. The -T says keep on pinging that address again and again and again until I tell you to stop. So we're getting a response. That computer is available. Let me rearrange my windows a little bit. I'm going to move PowerShell up here. I'm going to move my failover cluster window down here so we can watch the fun as I prepare to migrate failover demo from host 2 over to host 1. I'll throw a right click at it. My migration settings fall under a menu area labeled Move. There's quick migration. Here's virtual machine storage movement, by the way. Let me just take a quick look at it here. I can see my virtual machine here with a set of files in their current location. I can click and drag some set of files that I would like to relocate and associate them with a particular location. Let me drop them into the volume 2 directory, for example, if I chose to. That one goes, and this one goes. So I can click and drag files to be able to identify which ones are going to be copied where. I'll leave the VHD where it is, for example, perhaps. I can even copy from this cluster to some other server by specifying some file share that I want to migrate that content to. That works as well. In this case, though, I want to demonstrate the quick migration, so I'm going to throw a right click at it, and we'll move with a quick migration. I can select a node, in which case I get to choose which of the potentially 32 nodes in my cluster I want this VM to move to, if I've got a specific destination in mind. Or I can let failover cluster figure it out and let it move to what it thinks of as the best possible node. Now note that in that case, the list of servers that can be the best possible node will exclude the current node, even if the current node is the best, the one that's least heavily stressed by other operations. In this case, I've only got one place to go, so I'll choose best possible. And watch what happens in the failover cluster GUI. Watch what happens in my ping window as we prepare to do that migration. My virtual machine moves into the saving state, and you can notice immediately my attempt to get to that server from the rest of the network is failing. If I pull up the virtual machine window for that, you can see that the VM itself has moved into this grayed out sort of a state. It's unresponsive. I can't interact with the interface at all. Recycle bin? Nope, it's not going to open. It is in the process of saving that VM, 60%, 70%. Once it hits 100%, we're going to see it vanish from the list here on Hyper-V host 2. My connection window says, hey, I no longer see failover demo on host 2. Virtual machine may have been moved. Yeah, exactly. So let me exit out of that. Let's go take a look at things from host 1's perspective. Hey, look, there's a virtual machine starting up. 50%, 65%. Almost there. And you can do it. And it's running. Keep an eye on the ping window up top. Hey, look at that. We're now getting a response. So there was a recognizable gap of time during which that virtual machine was unavailable. In this case, it was a client OS, so probably not a huge deal. But imagine if that was our DHCP server, and somebody attempted to retrieve an IP address from the DHCP server during that period of time. They weren't going to be able to do so. They got a 169.254 address and called the help desk. So it's quick, but not all that quick. It is certainly going to be quick compared to our next big solution. The killer app for failover clustering with Hyper-V is called Live Migration. And the benefit of this is that I can get data to travel across from one host to another. I can move a virtual machine from one host to another. And if I do it right, if I've got a fast enough network, no clients notice any change in that VM as it travels from one spot to the other. Now, how is that possible? Well, we know that the storage is already in shared storage, so the hard drives are okay. The big things that need to get synchronized is the state of the VM, what's happening in its processor, but more importantly in this particular case, what's happening in RAM. Now, we saw that quick migration takes that RAM data, saves it to a file. That VM is in a saved state when the transfer happens from one host to the other. But what if there's another way to do it? Live migration is going to leave the hard drives as they are, but it's going to begin transferring data that's in RAM from one host to the other. Now that's a somewhat vulnerable technique because after all, as we transfer that data across the wire, the source virtual machine is still running, it's still performing tasks, its memory is being changed. Well, live migration keeps an eye on what's happening in memory in that virtual machine, and as data gets changed in memory, that data gets shipped across the wire. And more changes are made to RAM. We're creating what are called dirty pages in the memory management world. Dirty pages get shipped across the wire to my destination Hyper-V host. Once we reach a point of diminishing returns where we can't possibly keep up with the changes, the system pauses the virtual machine for a very brief period of time, transfers any remaining data pages to the other host, brings the machine back online, and if we have a fast enough network, that all happens within the TCP timeout window. TCP is the Transmission Control Protocol. It sets up reliable sessions between multiple computers. And there's timeout functionality tied to it. There are keep alive messages that pass back and forth between a client and a server. If the server doesn't respond within a certain amount of time, the client says, oh, something happened to the network connection, and down goes the connection. In a properly configured environment, we'll see that a Hyper-V failover cluster system can live migrate a virtual machine within the amount of time specified by that TCP timeout window. In other words, someone who's connected to a virtual machine on host 1 will continue working with it as it migrates from host 1 to host 2, and the client will not notice any change in the environment. As far as they are concerned, that virtual machine was a physical server that was up the whole time, rather than a virtual machine that not only was a virtual computer, but a virtual computer that drifted from one host to another during the execution of a file transfer or some execution of an application running on that computer. One other interesting technology at our disposal is Hyper-V replica functionality. This is a nice choice if I've got a primary site and a backup disaster recovery site at some distance from my network. If I've got a Hyper-V host that has a virtual machine on it, maybe I've got a collection of Hyper-V hosts that are all in the same office together, what happens if that office is hit by some sort of natural disaster? I might like to have a copy of that VM copied to a server at some distance from me. Some disaster recovery hot site, maybe just some other office within my overall national enterprise. I can configure that in the Server 2012 Failover Cluster GUI, identifying which server I want to be able to have my VM synchronized at, and when changes get made on my local VM, those changes are sent across the wire to the replica. When disaster strikes, I don't need to worry about where did I put the data tape that has the last backup from last week from that server, because the data is already on my replica server. I just need to start the VM there, and it's back in business. So let's take a look at where these things are configured in our GUI. So here I am in my demo environment. I've got my failover demo Windows 8 client machine still humming along nicely. I'm going to go migrate it over to host 2 again. I'm going to go throw a right click at it. When I do, I've got a couple of ways in which I can move that. We demoed quick migration and virtual machine storage. We can live migrate to the best possible node. Before I do that, let me pause to point out there's replication. If I want to set up replication, I'm going to ask the question, which other server out there, I don't have another server to move to in this case, but if I did, which other server out there is going to be the target of my replication behavior? In this case, though, we'll do a simple live migration. Where to? Let's send it to the best possible node, which of course is going to be host 2 in this case. It's my only other option. And notice we start the live migration process that I'm still able to ping the server. That migration process is happening in real time while my server stays running. In this case, it's a client computer, but you get the idea. While my virtual machine is still operable, we're migrating data about this virtual machine off of host 1, putting it on host 2. Once a sufficient amount of data is copied, we're going to cut over very swiftly from control of this on host 1 to control of it on host 2. And if all goes well, we'll see almost no downtime during that transition. Now this is going to take a little while to complete. We're effectively transferring the entire contents of RAM from that virtual machine across the wire. And my demo environment is not really all that fast. The efficiency of a live migration is going to be directly proportional to the speed of the link that you use between your failover cluster nodes. This is the time where if you want to be able to cut that migration time down, this is where you're investing in gigabit Ethernet or 10 gigabit Ethernet just to be able to provide a nice big fat pipe between my failover cluster nodes. This is going to take a little while to run, so I'm going to go ahead and press my magic train signal accelerator, and there we go. Now we're moving faster. Now you can see we've reached a point here where we are actually in fact beginning to time out. We've transferred the control of the virtual machine off to the other host. We're starting it up there. Virtual machine is running. We missed 5 packets. That's not bad. Contrast that against what we did when we did a quick migration, and that is no time at all. And quite probably, that little gap of time is not enough of a gap for an application that is waiting for a response from a computer to give up. There's a TCP keep alive timeout. It takes some number of missed packets for a computer to eventually give up and say, something went wrong. That connection has dropped entirely. And it's also worth pointing out, this is not a particularly fast-moving system. I'm using a couple of fairly commodity pieces of equipment, a laptop and a standard PC, as my lab environment here. Real-world modern production systems may well cut that gap time down rather substantially. So how about that? I was able to successfully migrate a computer with what may well have been an unrecognizable amount of downtime from the perspective of those that are connecting to this computer. Contrast that against the quick migration, which was indeed quicker, but at a trade-off of having much longer amount of downtime. Somebody connected to that computer would have a much longer wait before determining that that computer was back online again. So I hope you're looking forward to putting these ideas into practice in your environment. There's a number of really very valuable techniques that you can use for a variety of purposes to be able to support your failover cluster Hyper-V environment. Some of the other lessons in this course will give you some other perspectives on this same kind of an operation.